You ever get that feeling you know the physics, but the marks just aren't showing up on the exam? Well, today we're going to fix that. We're not just solving a problem, we're actually cracking the code of the official mark scheme so you can learn to think like an examiner and get every single mark you deserve. Let's get into it.
So here's our challenge, a classic GCSE physics question about a brick sitting in a swimming pool. Yep, looks simple enough, right? But trust me, the mark scheme tells a very different story. The difference between a good grade and a great one is hiding in the details, and we're about to dig them all up.
So what does a perfect full mark answer really look like? I'll give you a hint. It's not just about scribbling down the right number at the end. It's about showing your work in a way that proves you actually get the physics behind it. And today, we are going to unlock that secret together.
Okay, first up, let's tackle part one of the question. This one is all about the forces acting on our brick. So what exactly is the examiner looking for here? Let's find out. Okay, check this out. These are the three key points ripped straight from the mark scheme. For full marks, you've got to be super precise. It's not just a force from the floor. Nope. It's the normal contact force. Why? Because using that exact term shows you know it's a specific kind of reaction force, the one that acts perpendicular to the surface. And see this last point? Instead of just saying the forces are balanced, you have to spell it out. Weight equals upthrust plus the normal contact force. That's the detail that gets you the top marks.
And oh, this is such a good little tip from the examiner's brain. You might think writing the resultant force is 0 is an easy point, right? Wrong. It's kind of like a trap. You only get the mark for that statement if and only if you've already listed all three specific forces. See? This is a perfect example of how they test your deep understanding, not just your memory. All right, forces, nailed them. Now it's time to crunch some numbers. This next part is worth a whopping 6 marks. So listen up, every single step is crucial. We need to be crystal clear and show everything.
Okay, step one. Nice and easy, but absolutely essential. We calculate the area of the brick's surface. They give us the dimensions in the question, so it's a simple multiplication. And just like that, boom, we've got our first mark in the bag. Easy win.
Now we're going to use that area to figure out the pressure. We're told the force is 637 newtons, so we just plug our numbers into the formula. Pressure equals force over area. Remember, showing this exact line of work is so important for getting the points. You do the math, and there it is, 25,480 pascals. That's another mark for us. And please, please don't forget those units. Okay, here we go, the final piece of this particular puzzle. We need to bring in that other pressure formula. Pressure equals height times density times gravitational field strength. We already have the pressure we just worked out. We know the height is 2.5 meters and gravity is 9.8. The only mystery left is the density, that little symbol, rho. So let's plug in the numbers and see what happens.
So you just rearrange the equation to get density on its own and bam, our final answer, 1,040 kilograms per cubic meter. And just like that, by showing every step, we've picked up all 6 of those marks. That is how it's done.
But hang on a second. What if you didn't think of using that pressure formula first? Does that mean you lose all the marks? Absolutely not. The good news is there's often more than one path to the right answer. And the mark scheme actually gives full credit for a totally different method. Let's have a quick look. So this other way, it starts by calculating the volume of the water that's been displaced. Then it uses the force they gave us to find the mass of that water. And finally, you just use the classic density formula, mass over volume, and you get the exact same answer. A different road, for sure, but it leads to the same destination and, more importantly, the same 6 marks.
All right, on to the final challenge. And this one is designed to really make you think. The pool suddenly gets way deeper. We've got to use what we know about proportionality to figure out the new force at the bottom.
The key bit of physics you need to remember here is that force is directly proportional to depth. It's a simple relationship. We already know the force at 2.5 meters, so to find the force at this new depth of 49.9 meters, we just multiply the original force by the ratio of the depths, the new depth over the old one. Just setting up this equation correctly is the first big step to grabbing these marks.
Okay, so you punch that into your calculator, and this is the number that spits out. But wait, hold on. Before you scribble that down and move on, there's one last very common trap we have to avoid. This is what separates a good answer from a perfect one. We need to round our answer to an appropriate number of significant figures.
If you look back at the numbers in the question, they're mostly given to 2 or 3 sig figs, so it makes total sense to give our final answer to 3 significant figures as well. And that gives us 12,300 newtons. That is the answer that gets you the final mark. And check this out. Another brilliant little insight from the examiner's notes. What if you made a tiny mistake? Say you used 50 meters instead of 49.9. Do you lose all the marks? No way. You can still get 2 out of the 3 marks. This is proof that the examiner cares way more about you showing the correct physics method than getting the final number absolutely perfect. This is why you always show your working.
Okay, let's just take a breath for a second. What if we actually learned from this deep dive into an examiner's mind? We've seen that getting full marks isn't just about knowing the physics, is it? It's about communicating what you know in the exact, precise way they're looking for. Let's boil it all down into a master strategy.
Here it is, your blueprint for smashing these exams. Step 1, use the exact keywords from the physics specification. Don't paraphrase. Step 2, show every single line of your working. Seriously, it's your safety net for getting partial credit. And step 3, always check the little details that make a huge difference, like units and rounding. You follow these 3 steps and you'll be well on your way to a top grade.
So, there you have it. You now know how to think like an examiner. The exam isn't some big mystery anymore, is it? It's just a system, a code, and now you have the tools to crack it. So get out there, practice these techniques, and show them exactly what you know.